This is part 2 of section 4.3. We have been expanding logarithms as much as we possibly can. Now, this one is as ugly as you are going to see, ever, okay? We have a lot going on. We have multiplications up here, multiplications here, we have exponents going on, we have a division, a lot of stuff. The first thing I see, if I look at this and I look for the last, I imagine plugging in a number for x, and I ask myself, what is the very last calculation I would do if I were following order of operations? I would have to plug in a number here and here, do each calculation completely, and then the last thing I would do would be this division. So that's the first thing I undo. This is the same thing as log. This is base 10, understood base 10. Okay, so this is log of the entire numerator minus log the entire denominator. Okay, so now I'm going to keep splitting these up. What I have here is log of 3 things multiplied together. So that means I'm going to be able to split it up into 3. It is this property, but expanded to 3 things multiplied, not just 2. Also in this step, I'm going to note that this is the cube root of 5 minus x is the same thing as 5 minus x to the 1/3 power. Okay, so what do I have? I have log. These are all added, so I have log of 100 plus log of x cubed plus log of 5 minus x to the 1/3 power. Okay, minus. Now right here, I have to split this up, but this minus sign is going to apply to everything after this. So I can think of this as being in brackets here. And the last thing I will do is do the subtraction. So if I do this and I just glance inside here, I have 2 things multiplied together. So I can split this up into an addition as well. This would be log of 3 plus log of x plus 7 squared. Okay, now I have a negative that's going to need to be distributed, and I've got several exponents here. Log of 100 is 100. Remember, this is an understood base of 10. 100 is 10 squared, right? So log of, this is log of 10 squared, okay, plus, here I have an exponent, and I can't just, simplify it completely away, so I'm going to make, you can take this 3 and move it down in the front, so I have 3 log of x, plus, again, take this exponent, move it down in the front, 1/3 log of 5 minus x, don't lose your parentheses. Okay, now I'm going to distribute my minus sign in here. This is minus log, well, this is base 10, but 3 can never be written as 10 to a power. So this is just going to say log 3. There's not much I can do with that. Minus, I'm going to take, that's a minus from this distribution, and I'm going to take this 2 and move it in the front. Okay, I am almost done. This log base 10 of 10 squared, that is simply a 2. So I have 2 plus 3 log x plus 1/3 log of 5 minus x minus log of 3 minus 2 log of x plus 7. Now, I wrote this out in multiple steps, but you're going to find the more and more you work these, that you're going to be able to combine several steps. And if it works for you, it works for you. With enough practice, and I know this is going to sound outrageous to you right now, but with enough practice, you'll be able to go from here to here without having to write anything else down. Do I expect that of you? Absolutely not. Okay? All right, so let's go the other direction now. Let's talk about condensing these things as much as we can possibly can. All right, and where possible, evaluate logarithmic expressions without using a calculator. So now we are starting on this side of our properties, and we're going to go back to this side. So I have log of 250 plus log of 4. These have the same base. You really need to check to make sure that you have the same base before you go and start to combine these things. Okay? I do have the same base, so I have this situation, log of m plus log of n, where the bases are the same, and this says you can take and multiply these two things back together. So this would be the same thing as log of 250 times 4. And what is 250 times 4? It's 1,000. And 1,000 is a power of the understood base 10. This is log of 10 to the third power. And you know the power here by you just count the number of zeros. And so using this property right here where we have the same base, this answer is simply a 3.